name is Tommy, and today we're learning about kinetic and molecular theory. So what does KMT assume? Gases are ideal, particles equals points or volumes negligible, particles collide elastically or no energy is lost when they collide, gases phase through each other, gases aren't ideal, or bigger particles affect pressure. So KMT assumes that gases are ideal. That's basically the way that it's basically the only way that we can really predict what they're doing is if they are ideal. So 1 is right. Particles equals points or volume is negligible. This one's also right because it allows us to just assume that moles of a heavier gas and moles of a lighter gas are bound to do in part the same amount of kinetic energy on the walls. So that's also true. Particles collide elastically, or they do not lose energy upon collision. So this is also right because otherwise a gas would kind of just die down. The pressure would just die down as particles collide with each other and dissipate energy. So this one's also true. Gases phase through each other. This is not true because it contradicts particles collide elastically, and plus it doesn't make sense for stuff to just phase through each other. So 4 is not right. Gases aren't ideal. Remember, we said that they are ideal so that we are able to predict them. Bigger particles affect pressure. Again, this contradicts particles equals points. Being bigger doesn't affect the pressure as much with kinetic molecular theory, and when we're assuming that the gases are ideal. So that's also wrong. So KMT assumes that gases are ideal, volume is negligible, and particles collide elastically. So with this graph, or Maxwell-Boltzmann graph, we have the relative number of particles graphed against particle speed for a gas. So if I were to ask you, if these are the same two elements or compounds, then which one is at a lower temperature? So the one to the left would be the lower temperature because the particle speed is lower on average and therefore has less kinetic energy, meaning that its temperature is lower. While this one is warmer because its average speed is more, then therefore it has more kinetic energy. So we can safely label this one as the colder substance and this one as the hotter substance. Now if they were different substances at the same temperature, which one would be heavier? Again, it's this one that's clumped to the left because on average that mass has less speed because it has the same kinetic energy but more mass. And if you remember the formula for kinetic energy, it's Ke equals mv squared. So if the kinetic energy is the same and we have more mass, velocity has to be less. And if we have more velocity and the kinetic energy is the same, the mass has to be less. So this is the lighter one because it's faster, and this is the heavier one because it's slower.